Hello, we're going to go over our exponents quiz review using our laws of exponents. Remember, we always want to have a positive exponent, not a negative exponent in our final answer. So when I look at 17a to the negative 4, I realize that that's really 17 times a to the negative 4. This 17 has an invisible exponent of positive 1. And that's just important to think about because I want to have all positive exponents when I'm finished with my answer. So a way that I can think about this problem is I realize that 17a to the negative 4 really is the same as making a fraction, 17a to the negative 4 all over 1. So in order to solve this problem, I'm going to draw myself a fraction bar. Anything that already has a positive exponent is going to stay in its same location in that fraction. If I have a negative exponent, I'm going to change locations in the fraction to make a positive exponent. So 17 to the positive 1 gets to stay where it is. A to the negative 4, I want that to be a positive exponent, so I'm going to move it to the denominator, and that gives it an exponent that's positive. So 17 stayed because 17 has a positive 1 exponent. On problem 2, I need to remember that this really means negative 1 times m to the 5th times 8 times m to the 3rd times 1 times m to the 9th. So once I establish that I have three exponents I can look at, three coefficients that I'm going to look at, I can multiply negative 1 times 8 times 1. Negative 1 times 8 is negative 8, times 1 again is still negative 8. So my coefficient is negative 8. And then I have a base of m, and so I'm going to multiply m to the 5th times m to the 3rd times m to the 9th. I'll keep my base and I'll add those exponents. 5 plus 3 is 8, plus 9 is 17. Okay, I'm allowed to have a negative number. That's fine. That's not the same as having a negative exponent. So my final answer is negative 8 m to the 17. Okay, looking at number 3, we're going to use power to the power, or power of a power rule. So we multiply our outer exponent times any exponent we can find inside the parentheses. So this is simply c to the negative 8 times negative 7, which equals c to the positive 56. Number 4, negative 29 to the 0. We know that any number to the power of 0 is 1. The way this is written, I need to take the negative of 29 to the 0. So this is going to be the negative of 1. 29 to the 0 equals 1. So this whole problem equals negative 1. As a side note, if we had had negative 29 in parentheses to the 0, see how this is different from what we had written? In parentheses, that quantity, negative 29, all raised to the 0, would equal positive 1. That is not what we had. Those are two different things. Okay, looking at number 5, we're going to break this up into just coefficients, and that's just the variable x, and then just the variable y. So first, in order to simplify this, I know that I can divide 5 into my numerator and into my denominator. So 5 goes into 5 one time. I still keep that negative sign because I haven't dealt with the negative. 5 goes into 25 in my denominator 5 times. X to the 8 divided by x to the 8, we know that anything divided by itself is 1. So that's just 1, and I'm not even going to multiply times 1 because I don't have to. I'm just going to leave that out. Y to the 9 over y to the 11. One way to think about this kind of a problem is to realize that you can choose the larger exponent, in this case the 11, and you can subtract exponents and then put your final answer in the location where you had your larger exponent. So this is not algorithm style, but this is a way to solve this problem. 11 is bigger than 9, so I would say 11 minus 9 is 2, and I would keep my answer in the denominator. So I'm just going to carry over what I know. I know I have negative 1 in my numerator so far, and I know I have 5 in my denominator. X to the 8 over x to the 8 equals 1, and I have y to the 9 over y to the 11. 11 minus 9 is 2. And I'm going to keep that variable where my larger exponent was, so it's going to be y squared in the denominator. If we wanted to use the algorithms to solve this problem, I would still have negative 1/5, because negative 5 over 25 simplifies to negative 1/5, times x to the 8 minus 8. Remember, we take the exponent of our numerator and subtract the exponent of our denominator. So 8 minus 8, and then times y to the 9 minus 11, taking the exponent of my numerator minus the exponent of my denominator. When I simplify this, I have negative 1/5. This is times x to the 0, which is, of course, 1. And then I have y to the negative 2. X to the 0 is 1. And so I end up with negative 1/5. And y to the negative 2, right now it's in the numerator. And I'm going to move it to the denominator and let it have a positive exponent. 6, I need to distribute that outer negative 3 exponent to every single exponent that's inside my parentheses. So this is a very, very common place for a mistake to happen. Negative 4 has a positive exponent of 1. So if it's helpful to you to write that 1, please write that 1. Negative 4 wants some power too. This is a silly way, but negative 4 wants the power, C wants the power, D wants the power. Everybody inside wants the power, so don't neglect your poor numerical coefficient. So here we go, we're going to multiply that outer exponent to every single exponent we have inside those parentheses. So I really am kind of distributing it to every single exponent inside. I now have negative 4 to the 1 times negative 3. 1 times negative 3 is negative 3. I have c to the negative 8 times negative 3. Negative 8 times negative 3 is 24. And I have d to the 4 times negative 3, so d to the negative 12. Now I want to rewrite that so that I have all positive exponents. So when I do this, I'm going to have my fraction bar. Negative 4 to the negative 3 is going to move down to the basement, down to the denominator. C to the 24 already has a positive exponent, so it'll stay in the numerator. D to the negative 12 wants to become positive, and so that will be d to the 12. So I'm going to pause right here for a moment, and I'm going to say that when we had our negative 4 inside these parentheses, it implies that it is negative 4 that's going to be raised to any power we give it. Okay, it doesn't really matter because our exponent is negative, so it's going to be a negative number anyway, but I'm going to prove this in just a moment. Our negative 4 is the quantity that's going to be raised to this power. So I have c to the 24th over negative 4 times negative 4 is positive 16 times negative 4 is negative 64. So fully simplified, my answer is c to the 24 all over negative 64 d12. So I'm going to pause here and I'm going to talk about how I know for sure that that negative 4 would be in parentheses. If I think about expanding this original problem, this was our original problem, all to the negative 3 power. This is a second way that we can solve this problem, and I'm going to cover up my other notes so that you're only looking at one thing. Okay, we know that we can rewrite this as a fraction so that we move the whole quantity down to the denominator. We have negative 4, c to the negative 8, d to the 4, and all of this, because I just moved it to the denominator, has a positive 3 exponent. So we know that what this looks like is 1 over negative 4, c to the negative 8, d to the 4, times itself 3 times, times 1 over negative 4 times c to the negative 8 times d to the 4, times 1 over negative 4 times c to the negative 8 times d to the 4. So in expanded form, I can see that I have negative 4 times negative 4, that's positive 16, times negative 4 is negative 64 again. So if I were to simplify this, my numerator is just 1 times 1 times 1. My denominator is negative 4 times negative 4, that's positive 16, times negative 4 is negative 64. In my denominator, I have c to the negative 8 times c to the negative 8 times c to the negative 8. So I will keep my base, and I will add my exponents. Negative 8 plus negative 8 is negative 16. Negative 16 plus negative 8 is negative 24. I have d to the fourth times d to the fourth times d to the fourth, so I'll keep my base, and I will add my exponents. 4 plus 4 is 8, plus 4 is 12. And of course, we know that we would simplify that so that we have this single element of our problem back up to the numerator. So I will keep my fraction. I will have c to the positive 24, and then my denominator is now negative 64, d to the 12th. Okay, and of course we don't need to have that coefficient of 1 because we know we don't need that. And so we'll just write that as c to the 24th over negative 64 d to the 12th. And we will double check that that's what we got before. C to the 24th over negative 64 d to the 12th. So there are multiple ways to solve these problems. And you can always check your work by imagining a different way. Okay, we'll do 2 more problems on this video, and then we'll continue on with the remaining problems in subsequent videos. Problem number 7. In order to multiply everything together, I have to take care of my exponent on the outside first. That's because of GEMDAS. GEMDAS tells me I can't multiply until I have dealt with an exponent. So this exponent needs to go to every factor inside those parentheses first. So I'm just going to bring down 4x to the third. I can't do anything with that yet. And then I have, remember, negative 3 is going to be in parentheses because it is already in parentheses. So it is the quantity negative 3 squared times the quantity x squared. If you need to prove that to yourself, expand that out and see what you get. You'll see that you get positive 9. Okay, I'm simplifying a little bit here. I have 4x to the third times 9 times x squared. So now 4 times 9 is 36. X cubed times x squared is x to the 5th. Keep your base and add those exponents. And number 6. Again, I have 2 things that I'm multiplying times each other, but I can't multiply anything together until I deal with those outer exponents. So I need to distribute that 3 to every single factor inside my parentheses, every single factor. So I'm now going to have 2 to the third times m to the 3 times 3, that's 9, times n to the 3, times, over here I'm going to distribute this outer exponent to every factor inside. And remember, our negative 2 is effectively in parentheses, so I have negative 2 to the power of 3, m to the power of 3, and n to the 2 times 3, so that makes that n to the 6th. I'll simplify where I can. 2 to the third is 8. I have m to the 9, n to the 3, and then negative 2 to the third is negative 8. And I still have times m to the third times n to the 6th. 8 times negative 8 is negative 64. M to the 9th times m to the third. I'm going to keep my base and add 9 plus 3. And then n to the third times n to the 6th. I'll keep my base and add those exponents together. And so my answer should be negative 64 m to the 12th, n to the 9th.